I think about this all the time. So I'm having a dinner party, and Isaac Newton is my special guest. So I bring him through some space-time continuum wormhole, and now he shows up at my table. Then I realized his head would just explode. Because I would go to the wall and flick a switch, and then lights would show up above his head. That would just freak him out. That doesn't happen in 1704. And there'd be these things moving in the street. And he would say, well, what is that? I say, well, it's a horse-drawn carriage without a horse. We call them cars. Well, what makes it go? I would say gasoline. Well, what's gasoline? Well, we get it from oil. What's oil? And what's an engine? And then if I was going to show him something that'll freak him out, I'd just pull out a smartphone and show him a calculator. And he would spend weeks on calculations that I can just do in a few seconds. And I can play music on my smartphone. He said, how'd you get an orchestra inside there? These are the questions I think he would ask. That has me wondering, if any one of us or I were transported 300 years into my future, how freaked out would I be? There's some rather inventive ways things can get around the world. My favorite is the snake, of course. No arms, no legs, yet it gets around just fine. I'm imagining an alien visiting Earth stumbling on a snake, the only creature it sees. And then it goes back and tells its home people, you're not going to believe what I saw. There's a creature on that planet. No arms, no legs. It can still get around. It detects its prey with infrared rays and can eat things 5 times bigger than its head. And they'll think the guy was on drugs. It's an ordinary snake sitting here on our Earth.
What I don't understand is, why is the Higgs boson important?
So, Matt, can I take this? I got this. Brian, I got this.
I'll check.
I got this. Other than it's important to physics, we have no idea yet how it will be important to our lives or to civilization. And your question was asked of the electron when it was first discovered. It was asked of quantum physics as a branch of our understanding of the universe when it was discovered. Yet quantum physics today is the foundation of the entire information technology revolution. It would take decades. If too many people are around saying, how does that put food on my plate? Then civilization stalls in that moment. So as scientists, we have to be content discovering something new without regard to its relevance to civilization, because history has shown that give it some decades, civilization finds a way to tax it. There's this talk about cloning Neanderthal because they found some tissue of Neanderthal in the ice. They shouldn't do it. I don't want Neanderthal walking around. No siree. You know why? Because we kill each other for less. We kill other members of exactly our own species for less. You're going to bring up something that's almost human but not, Neanderthal, and we're pretty sure that our cognitive abilities are greater than that of Neanderthal. How are we going to treat him? I don't trust us. That's why you shouldn't clone him, because I don't trust the behavior of human beings. No, you're not going to have weapons destroying satellites in space. You know why? Because you do that, your satellite becomes hundreds or thousands of pieces of broken hardware moving at 18,000 miles an hour that can take out your own satellites. It's the modern equivalent of trying to use mustard gas because you can't shoot the soldiers in the trenches. Let's do a mustard gas. Oh, the wind changed. Oh my gosh, now it's coming back in our face. So space warfare is not so much weapons, but access to information. And the second Gulf War was completely enabled by space assets. There are people say, oh, the full moon, it turns you into a werewolf. And I was thinking, how come they only turn into a werewolf when they notice the moon? They're not just walking around and just turn into a werewolf and then realize the moon is. So somehow they gotta notice the moon. And then the moon comes out from behind clouds. But the moon was full even when it's behind the clouds. It's full when you're in your basement. So maybe it's the light. They gotta see the light. Well, the moon reflects sunlight. So if the moon turns you into a werewolf, so should the sun. You have never met someone at a place unless it was also at a time. And you have never met someone at a time unless it was also at a place. We know intuitively that we need 4 dimensions to localize someone to meet up with them. Only 2 dimensions if you don't have tall buildings. You have tall buildings, you need the 3rd dimension. So you don't say, I'll meet you at the 20th floor of 721 Park Avenue. What time? There's a full 4 dimensions going on there. Just I want to convince you we live in a 4-dimensional world.
Einstein comes up with a general theory of relativity, and there's something called the precession of Mercury's orbit. Mercury's orbit around the sun did not exactly follow Newton's laws. And we astronomers, we said, there must be some planet that we can't see that's too close to the sun, lost in the glare, and that's tugging on it. That must be it. And we named it. We called it Planet Vulcan. We were completely happy just making stuff up to explain what we could not understand. And then Einstein says, here's general theory of relativity. Oh, and by the way, it warps space-time close to the sun, and that accounts for Mercury. Vulcan evaporated overnight. The strength of the tides that the moon creates on Earth is basically the same no matter the time of day or day of month. What happens is the sun also creates tides. If the sun's tides add directly to the moon's tides, you get higher high tides.
Okay.
And when it's like at right angles to it, it tamps down the moon's high tides, and you get what they call neap tides. My point is, when you say, oh, the full moon made extra high tides, no. It's because when you have a full moon, the sun's tides add directly to it. And so it's all about the sun, but nobody talks about it that way. It wasn't soldiers who invented the catapult. It was some engineer in the back room who said, hey, I can do this. And then military leaders said, let's take it. For physics, they made the bomb, and the chemists made the napalm, and the biologists might weaponize anthrax. What does the astrophysicist do? I care about things like dim things that I'll use multispectral imaging to detect. I care about sending moving spacecraft to intersect moving objects in space. I care about navigation, where I am on the sky and where I am on Earth.
And all of that could be used by the military.
All of that. A researcher named Miles Standish asked a question. What are the observatories that obtain the positions of Neptune, leading us to say that it's not following Newton's laws? It's multiple observatories over decades. He goes back and analyzes them. One of the observatories was the U.S. Naval Observatory. And he goes back to the observations and finds out something like the gearbox was cleaned or oiled or something. Somebody did something to the telescope before those observations were made. Anytime you do something to a scientific instrument, you have to calibrate it. He said, what would happen if I ignore these measurements and fit the orbit to the remaining measurements that are out there? When he did that, Neptune landed right on Newton's law, and Planet X evaporated overnight. There was nothing with a mass and gravity that was perturbing Neptune. It was bad data. I will defend AD and BC, Year of the Lord, AD, Anno Domini, and BC before Christ. I'll defend the use of those because a lot of hard work went in creating that calendar. The Gregorian calendar, which is now used worldwide, based on a Christian construct, but it had a lot of very interesting science that went in behind it. I'm not just going to swap out the words to de-religify it. I don't mind leaving credit where it's due. And so that I don't know any atheist that still uses AD and BC. Common Era, CE and BCE, and before Common Era. But who are they fooling? It's the same numbers of years. They're just trying to paint over a religious reference. And I don't have that much objection to the religious participation in civilization.
How will the universe end, and what will there be afterwards?
We have several ideas for how it will end. One, it'll just continue to expand forever as the temperature descends asymptotically towards absolute zero. And all phenomena and all processes will cease. All stars will burn out. They will shut off in the night sky one by one. And the universe will be cold and dark. But if the expansion of the universe, which is rapid and accelerating, is real and continues, that'll take us to the big rip. That terrifies me, because if the fabric of the universe stretches faster than the material substance can sustain it, then rips into the, Riccardo Giacconi. He knew if you want to see X-rays, you have to do it from above the atmosphere, because X-rays don't make it through the ozone and other particles in our atmosphere. Well, if you're going to launch something, it can't be too heavy because it's expensive to launch heavy things. It's got to be light. It's got to be portable. So he was one of the founders of American Science and Engineering, a company based in Cambridge, Massachusetts, that pioneered small portable X-ray detectors in the 1960s. What was going on in the 1960s? Oh, they were hijacking planes to Cuba. People were taking guns on planes. Congress said, we need a way to stop guns getting on planes. We have American Science and Engineering providing the first X-ray detectors at airports, enabled as these portable devices because they're trying to put them on a satellite into orbit. He would ultimately get the Nobel Prize, and I was on the presidential committee that awarded him the Presidential Medal of Science. And when you get the Presidential Medal of Science, everyone goes to the White House. I get invited to the White House. And here comes Riccardo Giacconi to the White House, and you go through the security, and what does he walk through? An American Science and Engineering metal detector.